We know we can monitor the loss function to see when our model converges. We know we can listen to samples to gauge artistic qualities. Are there other ways we can measure music quality? We can measure how close the model is at mimicking the style of our data, and we call this the similarity index. You can see the similarity index as value plotted over time, for example epochs, on the left graph. The closer the generator comes to the real samples, this index should tend towards 0. When the graph smooths out and there are less spikes, the model has found a sweet spot, and we call this convergence. But there's really no better way to tell if your generative model is doing a good job than to listen to it. So let's listen to the output at a few epochs. Let's listen to the music at epoch 3000. Let's listen to the composition after 10,000 epochs. And finally, let's listen to the composition after 20,000 epochs. You'd see that the model improves over time as the machine learning model trains further. Now let's take a look at the training architecture. The user launches a training job from AWS Deep Composer console by selecting the various hyperparameters and dataset filtering tags. The backend control plane consists of an API layer, which is API gateway and Lambda functions, which write the request to DynamoDB. This triggers a Lambda function that starts the training workflow. The asynchronous workflow function, using AWS step functions, launches the training job on Amazon SageMaker and continuously monitors the status to update the DynamoDB about the status as it is required. The console will meanwhile continue to poll the backend for the status of the training job and update the results live, using which users can see how their model is learning. So what are some challenges in training GANs? Clean data sets are hard to obtain, and not all melodies are going to sound good in all genres. Just as in real life, for example, EDM melody, if you're using a classical model or a symphony model, something that the model has never seen an example of an EDM melody before, it's not going to do a good job at generating a composition. Convergence in a GAN is tricky. The discriminator feedback gets less meaningful over time. If the GAN continues training past the point when the discriminator is giving completely random feedback, then the generator starts to train on junk feedback and its own quality may collapse. For a GAN, convergence is often a fleeting rather than a stable state. There's complexity in defining what constitutes a good music. And lastly, there's complexity in defining the quantitative metrics for music creation. For example, the metrics to differentiate one genre from another or good music from bad, for example.